All right, IED, welcome to activity 3.1.1, which is going to be reverse engineer a product. In this activity, what we're going to do is we're going to take a solar powered calculator and we're going to completely disassemble it. We're going to perform a visual, a structural, and a functional analysis on the calculator. And whenever we do that analysis, we're going to organize our thoughts and we're going to make a presentation about those thoughts. So the materials that we're going to need in class are a solar calculator, reverse engineering toolkit, some calipers, and some presentation materials, either a presentation board or we'll make a digital presentation or something. For virtual students, you're going to be making a digital presentation for it. So keep in mind how to give effective presentations. You need to be able to have all of your information readily available, and you need to make it like straightforward and easy to read and easy to understand. So whenever you do your three analyses, it's going to be important to have a couple of slides for each one that basically shows you all of the important information that people want to know about this calculator. Because we're going to tear it apart and we're going to literally see what makes it tick. So, um, we're going to work in groups in class. If you're virtual, you're going to have to look at the teardown of this really, really cheap solar powered calculator that I found on YouTube. So it's a Dollar General calculator, and you can see this person actually take it and tear it to pieces. And you're going to do the functional analysis on this calculator right here. We're going to have similar ones in class, and we're going to be disassembling them as well. So what we're going to be doing is we're going to, in our colored groups, either red, orange, yellow, green, blue, or purple, you're going to grab a solar calculator and the toolkit, and you're going to make a plan to figure out where you're going to actually like document all of your findings and where you're going to collect your information. And after you do that, you're going to conduct a visual analysis. So, to conduct a visual analysis, it gives you a couple hints at what to do. It wants you to take some pictures for things at different angles, or you could just make a sketch. You could sketch a top, front, and side view of the object, and that would also count as well. You're supposed to create an inventory of images with titles that identify that particular view, the front view, the side view, or the isometric view. And then for each image, write a description of the visual design principles and elements that are evident from that particular view. So if you need to go back and review activity 2.2.2, which is how to do a visual analysis and the elements and principles of design, you might want to click on that link. Or if you're on the Project Lead the Way curriculum, you can just go click on activity 2.2.2 and you will go find it. I also have a YouTube video as well about it too, so you can go back there and check those. Um, so, and then after you perform your visual analysis, you're going to perform a functional analysis. And they give you a couple of hints on what to do there as well. Identify the product's name and the company's name. Identify the purpose or the primary function. Sketch an isometric pictorial of the product and label the individual components. If you're not sure what a particular component is called, just make a logical guess. You don't have to know exactly what it is. Whenever you open up the calculator, there's going to be a lot of things that you're not really going to know what the name of it is, and you're just going to have to make a good of a guess as you can. Let's see, identify the system inputs, the intended output function, or sorry, the intended product function, and the outputs. And then document what mechanical products are visible, and then document what you cannot identify because the mechanical components are hidden from plain view. So remember, you haven't actually opened this thing up yet. So whenever you perform a functional analysis, it's important to note that you're going to be doing a functional analysis of this object without actually tearing it to pieces. Okay? So you're going to just look at the buttons themselves and you're going to record the functions or what you think is the functions of all of these parts that are on the top of the calculator. And if you need a hint on that one, you can go to activity 2.2.3, and that will give you a couple of hints on how to do a functional analysis. And then after that, we're going to do a structural analysis, which if you're virtual, you're going to have to watch the person actually tear this apart. If you're not virtual, you're going to have to actually tear the product apart and see what it does. And you're going to have to identify each part of your product by name, quantity, size, function, material, finish, interaction of parts, and general notes about it using the product disassembly chart. I really wouldn't write that on paper. I know a lot of students really want to write this stuff on paper, but I would honestly download the product disassembly chart and I would write it all there by just typing. That way you can share it with other people easily. If you needed to print it out and make extra copies, you could totally do that as well too. It's a lot better off to type those pieces of information in than to write it down. Writing it, unless you're putting it in your engineering notebook, paper tends to get lost very, very quickly. All right, and then for the last part, research materials used in different components and investigate how material properties contribute to the functionality of the product. So you're going to have to try to research on what each one of these products are made of. So, there's a lot of plastic here, but not everything in this calculator is plastic. So, and even if it is, you can't just say like plastic. You have to tell me like what kind of plastic do you think it is? Are there any indications that you could see what kind of plastic it is? Um, and let's see, how would those properties how would they contribute to the functionality of the product itself? And then afterwards, we're going to share our findings. So it says to prepare a digital presentation to display from your analysis, and it includes these things. You need a photographic image of the product, a photographic image of each part with the label and material type, the visual analysis with the description of the visual elements, the functional analysis with the operation of the product, the completed structural disassembly chart, and analysis of how the material properties contribute. So, you're basically putting everything that you find inside of the presentation, but you need to put it in an organized manner. And there's a couple of different helping principles that I gave you guys. So there's building effective presentations that you can look at, and there's delivering effective presentations that you can have to look up if you need to. Okay, you can also Google those things as well. So if you want to try to figure out how to make a effective presentation, there's an excellent thing to try to Google. And that's going to be it for this assignment. So this is activity 3.1.1, reverse engineer a product. You guys have a great day, and I'll talk at you later.